Load calculations for a three-phase service involve several steps. Firstly, you need to determine the stinger leg voltage. In a three-phase delta system, the stinger leg voltage is usually not specified. However, by convention, it is often assumed to be 208 volts for 120/208 volt system or 240 volts for a 120/240 volt system. If the service is 120/240 volts, it is reasonable to assume a stinger leg voltage of 240 volts. Secondly, the next step involves calculating the phase current for each load. The formula for calculating the phase current for a motor is phase current equals motor horsepower times 746 watts divided by voltage times power factor times efficiency. Assuming a power factor of 0.9 and an efficiency of 0.9, the phase current for a 20 horsepower elevator would be calculated as follows: phase current equals 20 horsepower times 746 watts divided by 240 volts times 0.9 times 0.9, which equals 44.2 amps. For an A/C unit, the phase current can be calculated using the formula phase current equals compressor size in tons times 0.6 amps per ton. Therefore, the phase current for a 5-ton A/C unit is phase current equals 5 tons times 0.6 amps per ton, which equals 3 amps. Thirdly, the phase volt amperes, or VAR, needs to be calculated. This is done by multiplying the phase current by the phase voltage, following the formula phase volt amperes equals phase current times phase voltage. For the elevator, this would be phase volt amperes equals 44.2 amps times 240 volts, which equals 10,588 volt amperes. For the A/C unit, this would be phase volt amperes equals 3 amps times 240 volts, which equals 720 volt amperes. Fourthly, to calculate the total volt amperes on the stinger leg, you need to consider that the stinger leg carries the current from all three phases. Because the currents are balanced in a delta system, the volt amperes on the stinger leg is equal to the sum of the phase volt amperes. The formula is stinger leg volt amperes equals 3 times the sum of the individual phase volt amperes. Therefore, the total volt amperes on the stinger leg would be calculated as stinger leg volt amperes equals 3 times 10,588 volt amperes plus 720 volt amperes, which equals 34,944 volt amperes. Therefore, the total volt amperes on the stinger leg is 34,944 volt amperes. It is always a good practice to round up the volt ampere values to account for any inaccuracies or future load increases.